Bismillahirrahmanirrahim. Assalamualaikum and good days. Today we are from Group 7 of Section 2. Will be present the Engineering Mathematics Problem-Based Learning PBL assignment. So first and foremost, Khairul will explain the problem statement.
Assalamualaikum. My name is Khairul Hakim bin Khairul Anwar with metric number AA200944. So now we'll continue the presentation by state the problem statement. So for question 7 of population, the information given are the rate of increase of bacteria is proportional to the number of bacteria P present at time hours after the experiment. The beginning number of bacteria is 10 to the power of 6 and after 1 hour is 10 to the power of 9. So the first problem statement we found is which chapter is involved in this question. So this question is an exponential growth and decay of the population chapter. Other than that, our group found other problems. What equation do we need to use when solving this population question? So one of the equation that we can use is stated in the slide. Finally, another problem that we find out is what is the concept that must be applied regarding to the exponential growth and decay. Now for the second problem statement, for question 7 of Newton's law, first information given is a body at a temperature of 80 degrees Celsius is placed in a room whose temperature is 15 degrees Celsius, and it takes 15 minutes for the temperature to reduce to 60 degrees Celsius. This means the body temperature drops when it placed in a room with constant temperature. So this is a cooling phenomenon in certain period of time. The first problem statement we found is what chapter is involved to solve this question that are related to cooling. The chapter we can refer to is Newton's law. Next problem statement that we found is what equation that we need to use to solve this equation to this question. So now I will present the filler table for question 7 part A. Problem format: in a particular culture, the rate of increase of bacteria is proportional to the number of bacteria P present at time hours after the experiment. Given that the number of bacteria at the beginning is 10 to the power of 6 and after 1 hour is 10 to the power of 9. For the facts: 1. The rate of increase of bacteria is proportional to the number of bacteria. Ideas: number 1, the number of bacteria at the beginning is 10 to the power of 6. And number 2, the number of bacteria increases gradually against time simultaneously. Learning issues: number 1, what is the number of bacteria after certain times of experiment? Number 2, how much is the time taken for the bacteria or the number of bacteria to be much times the original number? And finally, the resources needed: number 1, calculator; number 2, reference in internet; and number 3 is from group discussion.
Hello, my name is Muhammad Amir Haris bin Muhammad Abu Bakar. So for the filler table problem format, Newton's law of cooling states that the rate of decrease of temperature of a hot body is proportional to the difference in temperature between the body and its surrounding. A body at a temperature of 80 degrees Celsius is placed in a room whose temperature is 15 degrees Celsius, and it takes 15 minutes for the temperature to reduce to 60 degrees. So for the filler table, the fact, the rate of the change of temperature of a body. So the ideas is after being placed in 15 degrees Celsius room, the temperature and time taken in minutes of a body are inversely related. At the same time, the body temperature lowers steadily as time passes. For learning issues, how do you calculate a person's temperature once they have been placed in a room? How can you figure out how long it takes the body to cool down by a particular amount? So resource needed is calculator, reference in internet and group discussion.
My name is Muhammad Haziq bin Zainuddin with number matrix AA200127. Okay, next we move to the solution for the problem. For the question 7 part A, the question is, in a particular culture, the rate of increase of bacteria is proportional to the number of bacteria P present at time hours after the experiment. Given that the number of bacteria at the beginning is 10 power of 6 and after 1 hour is 10 power of 9. Find A, the number of bacteria after 5 hours, and B, the time taken for the number of bacteria after to be 3 times the original. So we can see the scope of the problem is about the population of growth. So for question A, the information given from the statement is the number of bacteria at the beginning is 10 power of 6. Then the number of bacteria after 1 hour is 10 power of 9. First step, we need to find the proportional constant, which is K. So for this problem, we can use the equation of growth model formula to find the K. So the formula is PT equal to P initial E power of KT. Then we fill the formula with the numbers. After that, we got K equal to ln 10 power of 3. Then we need to find the number of bacteria after 5 hours. So back to the formula, because we want to find the number after 5 hours, so substitute T to 5. And then just solve the equation. And the final answer we got P5 equal to 10 power of 21. So for question B, find the time taken when the numbers of bacteria is 3 times than the original. So to find T, which is time, fill the formula with the information given. Then we can simplify the equation by making the initial population equal to 1. So we got 3 equal to E power of ln 10 power of 3 multiplied by T. Then we can just solve the equation. So the final answer we got is 0.159 hours, or we convert to the minutes, so it becomes 9 minutes and 54 seconds.
Assalamualaikum and good days. My name is Akram Shafaz Nil bin Azrin with metric number AA200543. Now I will explain the solution for question 7 part B, the Newton's law of cooling. So before we go through the solution, we must understand the general equation of Newton's law of cooling. So based on Newton's law of cooling, it states that the rate of change of temperature should be proportional to the difference between the temperature of the object and the ambient temperature. Based on the mathematical terms, Newton's law of cooling tells us that the rate of change of temperature with capital T with respect to time, lowercase t, should be proportional to the difference between the temperature of the object and the ambient temperature, d capital T over d small t. A decreasing temperature will imply a negative instantaneous change. The way that would happen is you would have a negative K. By solving this general equation for a general solution by separable differential equation, the simpler function we will get is function of t equals to Te plus Ae to the power negative Kt, where T is function of time of temperature, T is temperature of the environment, A is the change of temperature, and K is constant. So this is the steps on how to solve the general equation. Next, by using the function that we had solved earlier, we can solve our question. Based on the question 7 part B, the information given are temperature of the environment Te is equal to 15 degrees Celsius, To is 80 degrees Celsius, and T15 equals to 60 degrees Celsius. For question 7a, based on the function, to find the temperature of the body after another 10 minutes, we need to find the value of K. By substituting the information given of the 15 minutes into the function, we will get function of time of 15 minutes equals to 15 degrees Celsius plus bracket 80 degrees Celsius minus 15 degrees Celsius, or the change of temperature, and then times with e to the power of negative k, and then bracket 15. Thus, by solving the function, the answer of constant k we will get is k equals to 0.025. Hence, by substituting value of k into the function, the temperature of the body after another 10 minutes is 65.62 degrees Celsius. Next, for question 7b, to calculate the time taken for the body to reduce its temperature from 60 to 20 degrees Celsius, we will use the same function. However, instead of substituting the function of the time taken, we substitute the function to the value of the temperature itself. Hence, when we substitute the information, the function of this question is, instead of TT, we use 20 degrees Celsius itself, where we need to find the value of T. By solving this function, hence, the time taken for the body to reduce its temperature from 60 to 20 degrees Celsius is 1 minute and 43 seconds.
Assalamualaikum. My name is Muhammad Faris Farhan bin Abdul Ghaffar, number matrix AA200500. So today I want to explain about the conclusion from question 7 PBL. So the rate of exponential growth of bacterial culture is expressed as generation time, also doubling time of the bacterial population. So the main objectives that we need to achieve from this question is about, we need to figure out from the question 7 how was the number of bacteria increasing in 5 hours and the reason of increasing. So we apply the formula for the question given and we got the final results. And from the conclusion, we can conclude that it is true about the facts that the rate of bacteria to increase proportional to the number of bacteria present at time hours after the experiment.
I, Muhammad Amir Haris bin Muhammad Abu Bakar, with matrix number AA200757. For the conclusion, according to the Newton's law of cooling, the rate of an object cools is proportional to the temperature differential between the object and its surroundings. From question 7, the Newton's law of cooling, the objective that we need to achieve is about how to calculate a person's temperature once they have been placed in a room, and how to figure it out how long it takes the body to cool down by a particular amount. By using the general equation of the Newton's law of cooling, we can solve the problem. For the temperature of the body after 10 minutes is 65.62 degree. For the time taken for the body reduced from 60 degree to 20 degree is 1 minute and 43 seconds. So, we can summarize the statement of Newton's law of cooling is the true. The rate of the change in time of the temperature is proportional to the difference between the temperature T of the object and the temperature of the surrounding TE surrounding the object. That is all from our group. Thank you.